So, yesterday I posted a video about me doing, like, setting up the project, but now it's time to explain what the fuck is CGA. And CGA stands for Color Graphic Adapter, and was one of two cards that was published by IBM 45 years ago for the IBM PC. That's what it looked like. Um, so so the game is gonna run on this. The other card was a text card, so I don't think we need that. And basically, CG was a very basic card that should not be used to make video game, but as the popularity of the PCs, some still add the CGA, so it's kind of fun to just go and make a game on it. It didn't allow for a lot of colors. In fact, it allowed for enough colors for making crafts. So we had these hot colors. We had the cold colors. Those are different palette for the CGA Mod 4. We can the very this kind of like magenta, cyan, black, white is pretty much the standard one. You see every how we can access these mode. We get mod 4 with palette 0 and palette 1, low intensity, high intensity, and we get mod 5, low intensity, high intensity. Basically, we had a text mode and a graphic mode. For this game we're gonna use the graphic mode, but kind of see what every those are very 300 by 200, 320 by 200s. It's not a very good resolution, but get the job done. So basically we're gonna have a display that's gonna have this is a pixel. Every pixel is colors, and you can change the color for I don't know, black, and this one's white, or this one's well, let's say it's the first color, color 1, color 2, and you can change it. You can ask the CPU to do that. But in the memory, we got multiple bytes setting as that's a widescreen, and it's basically 11111. I just remember a byte is not that's a byte. Wait, no. Is it 4? Yeah, that's a byte. I'm such a dumbass. I was thinking of 8. So basically, we had, for every pixel, we had 2 bytes. And why is that? Because this is a 2 BPP, or 2 byte per pixel, 2 bit per pixel. So we had a choice of colors, and in this way, you can easily, if it's set in a certain form, you can change the palette very easily, because this is not oh, you didn't choose the color. You have a set of colors, you just choose the palette, and the image is already encoded in a way that changing palettes is very easy. So that's why you get those 3 palette you can have, and with different intensity. So basically we're gonna work with 320 by 200 resolution, and this is constituted at 40 characters by 25 lines. You can see it's written just right here, I think. Yeah, that's 40 by 25 mode. That's the aspect ratio, yes. But it's gonna be a text game, so we're gonna put screen. Every little square you see is gonna be a text. But we also want image. So what I'm gonna do is I'm gonna split my screen between the image. So this is gonna be the 40 character by 16 line, We're going to keep 8 line for display text for the player, and we're going to keep 1 line for the player to enter information. I don't know, something like kill. But this 40 character is 200 pixels. This 16 line is well, this 25 line is the 200 pixels. So what we're doing here is we're splitting the pixels. So here I'm dividing 16 is actually 128 pixels, and so we're gonna have an image of 320 and 128. It's not a lot, but it's gonna be enough. So yeah. What am I gonna say more? Yeah, we can't, like I said, we can't really like just load a BMP file or some PNG. Like this gotta be like placed in a certain way, and since it's not like every bit is a pixel, like every 2 bits is a pixel, we're gonna need like to count our bytes. So every like 40 characters is like, I mean, this is 40 byte. Every 2 bytes a pixel. So 1 line is actually 4 pixels. The 300, it's basically 300 divided by 4. Which I am sorry, I suck at math. So 300 divided by 4, 80. Okay, all right. So 80 bytes per line. So we're gonna have to write in a certain way as to like, okay, basically we're gonna make a .CGA format file to load our image on the screen. But anyway, so I already made a Python script, but I'm just gonna like explain it. So let's go. Alright, so I'm back. Remember last time we made this, I changed the DOSBoxX.config. Basically, I just removed the copy and put it in a make.bat. So I copy this and I just launch the DOSBox and then it execute this. So it should run pretty, like, I just have to do like, it should actually just run our code. Here you go. Hello world. What we're gonna do is I have a BMP here made by my friend, and as you can see there's multiple shades of colors, but we're gonna like put this together and try to get an output out of this. So if you don't have Python, I recommend you install Python. I'm going to use Python 3.10, but everything I use, I don't know why did I called it Python. I'm going to call this file a BMP to CGA. So everything that can use the pile script, it says I want to use 3.10. I forgot my Python. Alright. So import pill from image. So everything that can use this is gonna be fine. Oh wait, no, it was from. It just doesn't make sense though. Alright. Alright. I'm sorry. I'm just a bit rusty. We'll also need an sys for, I'm not gonna, I don't want to put like the name of the file. I have 3 BMPs right here, so any image is fine. But the thing is, I don't want to write the name of the file in the file, the script every time. So I'm just gonna like make a function. It's gonna be called convert BMP to CGA. It's gonna be having file path and an output path. Basically, I'm gonna pass this the sys.argv. This is gonna give us what I'm gonna call the script, and this will give us like 0 is the name of the script and 1 is the first argument you're gonna give. We're only gonna use 1 argument, so I'm just gonna put 1, and I'm gonna just call this, the name of the output file is gonna be output.cga. So write this, let's test it out. If you can't like run this, run and debug. Not the Python debug, I just want to run this right here. Should give us traceback. Why? Oh yeah, because you see I just wrote this without like any output. I'm just gonna put triple the name of my file, and it should just know that let's test this out. Like I'm just gonna write print sys.argv1. It's gonna know that as you see, it knows the name of the file. All right, so just delete this. Let's make the file. I'm gonna make something first. CGA palette. Make a define what's the CGA palette. So the CGA palette is 4 colors. So first color is going to be black. The last one is going to be 255, 255, 255. That's black. That's the white, and we got the second color. Apparently is cyan. Cyan is 0, 255, 255. That's cyan. And we got magenta. Magenta is 255. Oh no, we don't want to use the magenta. We want to use the mode 5. So basically, we want to use this. So it's background, cyan, red, light gray. So we're gonna use more like slightly less intense cyan, but like I want it red. I want red. Everything that's gonna be red. So we're gonna choose between these 4 colors in our convert, and we're gonna put them either 0, 0, 0, 1, 1, 0, or 1, 1. All right. So we're gonna use our PIL. I think it's Pillow the name, but I don't really know. So our image is gonna image dot open. We're gonna pass the path and I'm gonna resize. Like I said, if you get an image that's like double the size, it's good to resize to the proper, like, if needed. 300. I think I need to put this into. No, wait, it's not 200. It's 128. Alright. Image is gonna be converted to RGB, so we get like the red, green, and blue colors. Alright, so another thing I need to talk about is something very in the memory. Like this first line is going to be stored at the address B800. And I think it's like, then it does like some kind of index, 4 zeros. So that's the first address of the first line. But this is like the first pixel here. That's the first pixel. That's the address. The second one, it's gonna be here. Like here, this one. This one, it's not gonna be like, oh, it's like 80 byte later. No, that's I think it's 88. Yeah. So you see, there's, but then it goes back to being like the next after this one. So what it does it's called an interlace. So it's gonna be like this line, then this one, then this one. So every even line is close together, and every odd line is another part in memory. And begins here. So we gotta keep this in mind, that since we don't, if we make like a 320 character, we just have to place like, every even line we just put in the end, and we gotta like pay attention, because we also using, like, we're not using all the screen, but that's when we're gonna put the image on the screen. Right now we just gotta like focus on the fact that every 80 byte we're putting it on like another at the beginning of the file. So what we're gonna do is we're gonna separate these like this. And alright, so then we're gonna pass to every pixel in the image. So every line, image height. So it's gonna be a line of bytes. And this is going to be every X. We're good at doing and we're gonna like increase by 4, because we got 4 pixel by bytes. I forgot my little. Alright. Good. So byte 1, it's gotta be 0. We're gonna set this later. for every bit in like this 4 pixel by byte. We're gonna like set the pixel to the image, get the color. This will get us a 3-color well, the RGB value. So we need to do the pixel we're at plus the byte, the bit, and RY. Yeah, I think that's, oh yeah, that's like the first. All right, so okay, right, we need to get like one color from here. So I'm gonna like take closest CGA color. So because sometimes you like take an image, doesn't have the exact same palette that you set here, it's not gonna work. You want to be like very like certain. You gotta be 0, 0, 1, 1, 0, or 1, 1. So we're gonna return a value from here by like choosing the minimal the range in this CGA palette. The key is gonna be anything, and like, all right. So a sum of the color J, yeah, CGA palette, Y, I, J, and dot 2 for J and range 3. All right. This will give us the closest color in the when we're gonna do like the I guess the color of the RGB. We're gonna like take every value here, we're comparing them together, and anything that's like minimal, we're gonna take it. So basically right now we get like a CGA color from this closest CGA color, get the RGB value. So right now we have the color of the pixel, and we just need to like put that like well, the value here is gonna be like, I guess, an integer, so we just want to use the 2 byte at the end. We don't really need the other shit. So it's gotta be an OR, that like we're gonna take the byte, we're gonna OR it, and we're gonna put it at the beginning. So we're gonna just take like the last 3 bit, I'm sorry. So X, we're ending it, then we're shifting it 6 times, 6 times minus the bit we're at time 2, because every pixel I use 2 bit. So, and we're doing this 4 times. So the first 2-bit is gonna be 6. The next one is gonna be 4. Yes, 6 times is gonna be 4. The next one is gonna be 2, and the last one it is not gonna shift at all. So the byte's gonna be done. Now we're out of the loop. We're gonna put this in the line byte. We're gonna append this into this. So right now, at the end of this, this is gonna be every line byte. We're gonna have like a lot of line. So we're gonna check if the line is, well, I guess that at the end of the range of the image width, because now the width is 320, we only need to check if the y is basically odd or not. So if it's like even, we're gonna put it in the even line. Extend line byte, and if the line byte is, if the y value is odd, we're gonna put it in the odd line. So this way we separate the bytes so they can be like put in the memory more easily if you want. I just prefer it that way. Like if I just like put it in inside one buffer and I have to like separate the buffer, okay, your line goes there, your line goes there. I just don't want to do that in the C code, so I just separate them like this. Just gonna facilitate our life later. So right now we're gonna write this in a file. So we're gonna open the output path that we had taken later. Write byte and as f for file. Yeah, file. I don't care. So our file, we're gonna write to the file a byte array, and the first one is gonna be the even line, and then we write all of the odd line. Right. So that's it. That's our Python file. So if we executed this, oh, what? Okay, 43. What have I done? What is it? Line 43 in module. Closest colors. Line 12. Range. Take no keywords. Argument. Oh, I'm sorry. I forgot this. Alright, so now we have an output CGA. If you have a X editor, you can see like we put a bunch of like zeros in one. So basically now in the next episode we're gonna put this in our C file so that we can see this image on the screen. Alright, see you later.